Okay, pause and copy, pause and copy. Blah, 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 blah. So, guessing is fun, but we want something more systematic, a method, a step by step recipe. Solving differential equations is a subject on its own. Okay, you can take many courses in differential equations. If you want to study them, you could make a career of researching different solution methods. But today we're going to introduce just the very first technique, which is called separation of variables. So that'll be our first systematic method. It works for some differential equations, but doesn't work for all of them. And we're going to see how separation of variables explains number 2 here. How can we recover more solutions? Okay, let's do an example. So we're going to solve y prime is equal to y. And we're going to use this technique that I alluded to. So what do? I first of all use the Leibniz notation. Oh, why do I have a z there? What is my independent variable? Let's go with, it doesn't matter. I'll go with t, since often our variable is time. So y prime becomes dy dt. Now, the separation of variables is quite simple. I'm just going to take this equation, treat this as a fraction, and I'm going to take my y. Everything that involves a y will go over to the left-hand side. And everything involving a t will go to the right-hand side. So we're separating the y's and the t's. Okay, let's do that. So I get 1 over y dy is equal to dt if we separate here. Okay, so this is separate. Okay, our next step is to perform an integral of both sides. This is all a little bit magical, but I assure you that a demonstration of the validity of this technique is in the textbook if you care to look at it. So now I'm going to integrate. So what I did, I just put an integral here, integral here. That's my next step. On the left-hand side, I have ln absolute value of y. On the right-hand side, I get just t. Now, when we do indefinite integrals, we typically have a plus c and a plus c. But what we're going to do is just combine those into a single plus c on the right-hand side. Now, what do I want? What am I trying to do? Let's scroll back up. I want to find y. Okay, so I'm going to try to solve for y here. So what you do is you want this ln to go away, so I have to use its inverse function. So I have to put an e. Let's go green. I put an e here. I put an e there. And I get absolute value of y is equal to e to the t plus c. And then what? Well, this is e to the t, e to the c, which is y is equal to, we'll put the constant first, e to the c. All right, where are we? If you have absolute value of y is equal to, let's say absolute value of x. Let's say I had absolute value of x is equal to, say, 7. Well, what do I know? I know that x is going to be 7 or minus 7. Right? So y is equal to plus or minus e to the c, e t. To simplify this expression, we'll say let a equal this plus or minus e to the c. And we should say something here. C is any real number. So e to the c is a positive number. So plus or minus e to the c is some non-zero. Could be negative. Now this stuff in red is kind of messy details. Let's soldier on here. So plus or minus e to the c is some non-zero number. Okay, so we'll say that a is any real number. Since we'll just, okay, let's just stop there for now. We'll say is any real number. So what do we get here? Y is equal to a e to the t, where a is any real number. Now, this stuff in red, unfortunately, we should talk about that some more. Okay, so e to the c is positive. Plus or minus e to the c could be positive or negative, but not 0. But what about 0? Why am I including 0 as a possibility here? Well, this is messy. You just have to check. Equals 0 is possible since y equals 0 is a solution of y prime is equal to y. Okay, yeah, because if you plug in 0 here, it does work. Okay, so here is our solution. And what have we done? Let's recap. Is I wrote the word is twice. Erase this is. All right. Let's recap. We wrote in Leibniz Notation. We did separate. We integrate. And then you solve for y. And you celebrate. Smiley face. Okay, so this explains why. Up above, we had, what did we have? This bit here, yeah. Okay, so it turns out that you can have any number in front of the e to the t, and you still get a solution of y prime is equal to y. Okay, separate, integrate, celebrate. Let's try another one. Y prime is equal to x squared y. Okay, so you get dy over d. Here, because of the presence of the x, I'm going to use x down here. So I want to separate, so I'm going to put my y's on the left, and then I get x squared dx over there. So I did separate, and then I integrate. X cubed over 3 plus constant. Now, same idea as before. You stick an e here and you stick an e there. The e and the ln cancel, giving you absolute value of y e to the x cubed over 3 plus c. So you get e to the c, e to the x cubed over 3. Now, just like before, we're going to have y is equal to just a e to the x cubed over 3, where a is any real number. Okay, to get from here to here, I did the same steps as in the preceding example. Okay, another example, different flavor. Y prime, come on, y single prime is 6x squared over 2y plus cosine y. So I separate 2y plus cos y. So the y's go on the left, and the x's go on the right. Okay, remembering that y prime is dy dx. Oops. And you integrate both sides. Plus sine y is equal to 2x cubed plus constant. Now, this one's different. Okay, we cannot solve for y. So we just stop here. Okay, this will happen occasionally. So what are my expectations? My expectations are, if you can solve for y, then you must solve for y. And if you cannot, or maybe it's just far too difficult, then you are not expected to solve for y. These two cases should be quite separate.